Hello student, I am Arnav Das. Today we discuss about some concept for the feedback and how it is work. Last day for feedback topology, initially we discuss about various kind of amplifier and they're broadly on relating the input and output classified into the four form and we discuss each and every one and they was voltage amplifier, current amplifier, transconductance amplifier and trans-resistance amplifier. Now, if we generate this kind of amplifier, that time also their concept or their feedback should be required to maintain that particular value. By a simple analogy, I think it will be little bit more comfortable for understanding. Let and involve an example. Initially, we just think that there a tap is present. This is the tap and it is open form. And this is an reservoir where water or any kind of liquid is coming. If there no control or no feedback topology is applied, that time what happened? Water or liquid maintain the coming at the reservoir, and if the outlet is as a stop condition or it is closed, that time when the time is passing, the liquid level or water level will be rise up, and ultimately when it is totally covered the tank, after that also the liquid or water will be coming through that particular tap. So on that particular situation of time, it may be happen that the overflow of water can occur, or if their overflow process cannot be applied, then can be this reservoir burst. So to overcome this situation, there a option should be present for this tab. That means if it is come to the ultimate tolerance position or ultimate position for the reservoir stored capacity, then automatically tap will be closed on there. This is a simple analogy is given to you that there an floating ball is present and which is connected with a valve as a pivot. When the level of water or liquid is increased, that time this portion also this portion also come to downward, and ultimately when it is come as a ultimate position, that time this knob position will be totally closed on there. So no water or liquid will be bypassed through that particular tap, and reservoir will be maintained as a fixed or desired level position. So this information, that is how much water you have to supply through the tap, it is controlled by this process. That is the feedback is coming. This is the level is how much you have to increase till. So this is a feedback which can control the reservoir water or liquid storage capacity. If it is come to the maximum level, then automatically this will be stop the flow of input water or liquid. So it is most advantageous for application in various fields. Now the question is coming that What is the feedback? Feedback is a technique where proportion of output of a system, that is for amplifier, is feedback and recombined with what input. Look that some portion of the output is come to here again at the input side. That means the feedback is process is going on there. On the basis of how it is work, that is the at the input side, how they combined on that point of view, feedback is basically two types. One is the positive feedback and second one is the negative feedback. If the input side, if we consider for the voltage, then if at the input side voltage level for the amplifier, for this section amplifier, as a magnitude rise or additive, that time this will be the positive feedback amplifier. If it is as a subtracting form or this is the lowering form, that time it will be defined as negative feedback amplifier. For the positive feedback is the process when the output addition or added to the input amplified again and this process continue. Look that already I told this is the additive nature. For the negative type of feedback, the feedback will be as a negative one. If we consider for the previous case or speed control, these are the typical example for the negative feedback amplifier. Now we consider for the negative feedback how it is work, and automatically the same process can be applied for the positive feedback also. Let for the amplifier, that is the input side, this is the open loop A, here input is xi and output is x0. So you can write down A is equal to output by input. So this is x0 by of x of I. You can be write down. So from this expression you can write down x0 is equal to A dot of xi. Now you consider for the beta this block. Here input side this one and this is the output side. So beta this one can be write down as a output by input. So this is x of f by of x of 0, because the x0 is now for this beta block is the input and x of f is the output for the beta block. So from this expression you can write down x of f is equal to beta into x0. If you consider for the x of I, so here this is x of I should be as a minus of x of f. So this is x is minus of x of, this is uh, x of f on there. Okay, if it is plus in nature, that time it will be positive feedback, otherwise each and every term will be the same on there. So for this total block, if we consider for this total block, the amplification factor is defined by A of f. This is the feedback, and for this reason I just write down here, or each and every book also prefer that write down there A of f. The gain This will be defined output for this total one block. Output is x0 by of xs. So this is given in there as a yellow box. So it will be as a value of a by of 1 plus beta of a. If individually you put the value, that time you can able to got the ultimate equation. For the positive feedback also you can try. Advantage of negative feedback, what? This is stabilization of gain. That means it's maintain the same gain. Same gain on there. Reduce the non-linear distortion. That means if there any distortion is occurred, negative feedback can little bit or most extent it will be reduced. Reduce the effect of noise and extend the bandwidth of the amplifier. That means the if you are not applying the feedback, that time if the bandwidth was x, then the after applying the negative feedback, new bandwidth which is come as a x of, as I said, 2 or x of f. So x of f is greater than the value of x. Modification the input and output impedance, and there's some disadvantage also present. The circuit gain will be reduced, stability will be tends to oscillate. So these are the advantage and disadvantage for the negative feedback. And when you ultimate go through the each and every one topic, then obviously we can learn about what will be the ultimate values coming on there, and why we telling that the negative feedback is no effective, much more effective um, for various specification. So already I discussed this kind of thing. Again, the same block is applied with the each and every clear notation. So please check this one. That is the capital A is defined as a open loop gain, that there's no feedback if you consider. B or beta, most of book it is provided. Beta is defined as a feedback factor, and there an summation or summer circuit is present. If it is additive in nature with the x of f, then it will be defined as a positive feedback. If it is negative, that time it will be negative feedback. X of I, which is the input for the A block, this one x of I, which is also defined as the error signal, because if there no differences occur, that time the value also will be as a 0 for the negative feedback. And we also know about that why it is come as such, and individual term also previous slide we discussed. So ultimately value for the A of is coming as the A by of 1 plus of A beta. So if A beta is very large, the overall gain become a function of feedback network only. So this is the most important point also. So A beta, if you convert into the very large value, then overall gain can be um, can be treated as the ultimate uh, quantity or specification for the feedback network. Basic structure is given to you here. For any kind of amplifier, there should be the signal source which is required to amplify, and the loads that you have to collect or extract the output with the desired form. and in between the amplifier there an open loop gain is present or forward transfer gain is present. This is the A, and the feedback path also present. This is the beta. So here feedback path is connect in between the input and output side. The connection from the output side to the feedback. This connection is typically named as sampling network, and where it is added, that is the input side, this one is defined as the comparator or mixer network. Okay, and how the sampling and comparator network you are applying on that point of view, various kind of topology name will be suggested on there. Basically for the feedback network, here the some portion for the feedback network is cutted on down from the previous image. So uh, for the feedback network, the block is usually a passive or two-port network. Most of cases it is done. It may be resistor, capacitor, inductor. Usually it is a simply resistive network. Okay, this is the most of cases, not necessary. Sometimes the active element, that is the diode transistor, can be applied on there, but most cases they are simple passive network, and it base or basis, this is the what type of parameter or what type of component you are suggest. On that point of view, they basically work as a resistive network form. So for the sampler circuit or sampling network position, that means the output section where it is connect with the input side. On that section, if it is connected as a sound form, look that there two terminal is present for the output side. This is for the register, there two terminal is present for the output side. There are two terminal, one is connect at the input side for the feedback network, so another one also the same as a parallel from with respect to the RL. That time, this kind of cases, the output voltage is sampled by the connecting the feedback network in shunt across the output, and type of connection is referred to as voltage or shunt or node sampling. So how can you memorize this one? They are the parallel combination or shunt combination, there which parameter is constant. So if you just recall your memory, then automatically answer will become as a voltage. So this kind of connection, their voltage is specified as a sampling network name. Now, if the connection for the sampling network is as a series form, that time what happened? You just recall from the same way for the previous cases, which parameter will be constant on there, current or voltage. Obviously for the series form, their current term is constant, so this is current sampler, it will be named. Okay, same thing is written on here also. The output current is sampled by the connecting the feedback network in series with the output. Type of connection is referred to as current or series or loop sampling. Now for the input side, how they are mixed the feedback output with the input, that is how to generate the V of I or error signal. On that point of view, this mixer network also too. So in here also looked at, there also series formation is present, or it may be parallel formation. If it is series, that time which term will be the apply as a feedback? Look that for the series, the voltage term will be applied as the input, because in this case the current term is the constant, so variable term is the voltage. So here voltage is the feedback one. Here voltage will be used as a feedback one. So this is voltage is used as a applied feedback. So identify as a voltage or series or loop mixing for this kind of comparator or mixer network. Now for the comparator of the mixer network, if it is as a parallel form. So here the constant parameter is the current. So which one, the variable one? Here the variable one is the sorry, here the constant parameter is the voltage due to the reason of the shunt configuration. So variable parameter is their current. So here feedback is applied for the uh, input side. This is as a current, and here also this is as a I of F. This is I of I is the error signal or error current for that one. So the comparator or the mixer network, in this case it will be specified for the current for applied feedback and identify as a current shunt or node mixing. So next day we will discuss for the four basic type of topology, and individually we also able to identify how they are effective for various kind of application. So today this is our total entire uh, topic we discuss. I think each and everyone can able to understand, and hope next day we should meet with this online field. Until have to say bye.